benefits of electric vehicles. Now we'll hear a little bit about an adjacent topic, which is how the inspection process works for electric vehicles. And we're very fortunate to have Andrew Cattell with us, who's the head of regulatory affairs for the DVSA, which, for those who are not familiar, stands for the Driver and Vehicle Standards Agency in the UK. He's got over 30 years worth of experience, an engineer by background, and I think he's also here in an advisory capacity as well. So, over to you.
Excellencies, distinguished guests, thank you very much for this invitation to speak with you this afternoon. I work for the UK government agency that has responsibility for inspection and testing of all vehicles in the UK. That's known as the Driver and Vehicle Standards Agency, DVSA. I also represent the agency on an international testing committee known as CETA. I'm here in the UAE currently on a secondment from the British government looking at periodic technical inspection, the annual test for motor vehicles, with particular attention on commercial vehicles. The main part of my presentation is about the inspection process for electric and hybrid vehicles, but first just a few words about CETA. CETA are an international non-for-profit committee that actually represent many stakeholders. They're involved in the common theme of road vehicle inspection. We have support from government, private sector, equipment manufacturers and inspection sites. And as you've heard earlier, we are also recognised by the UN ECE Working Party 29, the Vehicle Regulation Forum, for our expertise in inspection testing. We have around 120 members worldwide in almost 60 countries, and each year they test around 250 million vehicles. You will see that we have members in the Middle East, from Qatar and Dubai, and now indeed we have a member from Abu Dhabi. CETA's mission is dedicated to improving road safety and the environment, to provide a forum for the exchange of information about the inspection process and to provide input to the European Union and UNECE. You can see we have a number of different activities, and these include best practice and recommendations about inspection of all types of motor vehicles, from motorcycles all the way to agricultural vehicles. We have recommendations that support inspection methods, quality control and quality assurance, and inspector training, together with systems to improve consistency. I now move on to the main part of my presentation on what we need to consider in relation to electric and hybrid vehicles. After all, they are simply passenger vehicles that will need to be inspected at your test sites every year. We've already heard a few comments this morning about electric vehicles not being a new concept. As you can see here, indeed they have a history that, as we've said, dates back to the 1880s. But over time, they've had limited success, with other factors driving the vehicle agenda. In today's modern world, with constant demand for increased fuel efficiency and a reduction in harmful emissions, three types of small passenger vehicles we've heard have emerged: the hybrid electric vehicle, the plug-in electric vehicle, and the full electric vehicle. So what can this mean for our vehicle inspectors who are tasked with the annual inspection to make sure that these vehicles are roadworthy and they still have a good steering system, a good braking system, lights, tyres and other items to be checked? There are 5 topic areas that I've chosen that relate to the periodic technical inspection of these vehicles: the drive components on the electric vehicle, the effects of road safety and the environment, the effects of these components upon other components, an assessment of the potential risks, and changes to the requirements of the periodic technical inspection, the PTI, the annual inspection. In common with other presentations, a very small overview of the electronic equipment. As we've just heard, most vehicles, electric vehicles, will usually have several components that fall within the current inspection process, such as the 12-volt electric battery and the traditional, often internal combustion engine used on hybrid vehicles and its associated parts. These will not be uncommon to our vehicle inspectors, but inspectors will now need to consider the high voltage components that include things like the electric motor, the high voltage battery and the high voltage cables. Each of these components can have an effect upon the road safety and the environment. For example, electrical shorting of a high voltage cable due to ageing or wear characteristics will need to be considered. In addition, new high voltage electrical devices demand regular maintenance that may be dependent upon mileage, and of course this needs careful consideration to remove the potential for manipulation, one of the aspects that's covered during the annual inspection by identifying the mileage on inspection certificates. Similarly, the electrical components will constantly be susceptible to wear, leading to the production of harmful environmental pollutants. Imagine the new hydrogen vehicle with a broken sensor that results in the emission of an unwanted product. The effects of these inspections need to be considered by inspectors on other components. Inspection processes will often use more traditional components, but the new components such as regenerative braking systems may mean that how the foundation brakes work and how they are tested may need further design checks within the inspection test. An increase in weight as a result of the extra battery and associated components may also lead to changes in driveline wear characteristics, and indeed a more detailed examination of body structures may also be required. Similarly, hydrogen-fueled or fuel cell vehicles may need the examination of certain specified components. Potential risks can obviously be identified. Mark's talked glowingly about the aspects of safety within these vehicles. As ageing occurs, we need to consider the effect of the ageing of those materials on components within the vehicle. With any inspection process, it carries risks. This slide highlights electrical winding that has degraded with age or heat, which on high voltage cables could lead to further risk for inspectors. Independent inspection staff need, of course, to be properly trained to ensure they are aware of these risks and able to manage them. Inspectors will also need to be familiar, of course, with the differences between the high voltage system and the more traditional low voltage system, which carries no risk. The red sign on the left, components such as high voltage battery, the inverter and perhaps the electric motor, all present risks to inspectors which need to just simply be acknowledged and be knowledgeable about. Whereas the right or green side on my slide shows the more conventional components that inspectors will be familiar with. What we would never wish to see is, as with other presentations have mentioned within this conference, the risk to inspectors increased, escalating to a level that they become conductors of voltage through mishandling of components. Education and training is therefore key to risk prevention. To consider the effects of electric and hybrid vehicles upon the inspection processes, there are indeed few documents that are available. You see here there are two key documents that identify areas you should consider for your inspection manual and the process. On the right is the technical note, which is CETA Recommendation 1 about the inspection of these vehicles. And on the left, independent research that looks to support that recommendation. Both of these documents are then integrated into an inspection manual for private cars. This inspection manual on the left side is the UK-based private car inspection manual, and similarly on the right-hand side, the inspection manual that both incorporate CETA recommendations for the inspection of electric and hybrid vehicles. So what's actually inside these recommendations? Let's take a look by opening it up inside. The CETA recommendations fall within 7 key areas. They relate to the high voltage electrical marking, the regenerative braking systems, electronic power steering, low voltage electrical wiring, low voltage batteries, electric powertrain residual energy storage systems, and similarly electrical powertrain residual energy external charging systems. Over time, we shall see these recommendations enhanced or adapted to accommodate further alternative fueled vehicles. Within each of those recommendations, the detail of the item to be considered, which includes the method of inspection, how the inspector should be approaching the inspection process. It identifies the main reasons why the vehicle should not be issued with an inspection certificate, and these are shown within the red box area. You will also see on the right-hand side, within the red circle, defects that are identified during the inspection process are categorised according to their significance or severity. The categorisation of these defects, which will be incorporated into inspection manuals, lists 3 simple phrases: minor defects, major defects, and dangerous defects. The 3 classifications can be explained further as minor defects, which are technical defects that have no significant effect upon the safety of the vehicle. When an inspection process is conducted, one could suggest that these are defects which are identified to which the driver is advised upon. Major defects, however, that affect the vehicle safety or other vehicle road users. In these cases, where defects are identified that fit this standard, further use of the vehicle should be limited. The final category of dangerous defects recommends that in these cases they present an immediate risk to road safety and the vehicle should not be used on the road. CETA recommends that in this case that the owner or driver should be notified in writing that a defect has been identified that meets this standard, and the vehicle should not be allowed on the road until that defect has been repaired. In some countries, this also means that driving the vehicle from the test site after the inspection has been completed would not be allowed. Other countries have already adopted this system. This example is from another EU member state, and of course the inspection process is not simply confined to small passenger vehicles. You should consider the benefits of future mobility and its relationship with large passenger vehicles. Gas vehicles are again not a new concept and indeed have been available since the 1920s. Here we see a typical gas-powered bus that runs on main gas from the UK national grid. It's treated and compressed into tanks on the roof and provides enough energy to run for 300 miles each day. It's much cleaner. Continuing this theme further, we have seen earlier from Dennis's presentation a groundbreaking trial that was launched in the UK, operating 8 battery electric buses, which are topped up by the contactless recharging points on its roof. The wireless charging technology lets the buses run all day and was forecast to save 600 tonnes of CO2 emissions each year. You can see the charging plates at the base of this picture. But of course, a big player in the UK market are the hybrid buses. The introduction of hybrid buses form a major part of ongoing commitment to green energy. The hybrid vehicle is one that takes its power from more than one source, and in this case a diesel engine and an electric motor. What makes these buses so different is that both units can work independently or together. When the bus accelerates away from a bus stop, the electric motor works alone and uses the stored energy in the battery to power the vehicle. During this time, the diesel engine is not used, saving fuel, removing emissions and reducing noise pollution. Only when the bus reaches speeds of approximately 15 kilometres per hour will the small diesel engine start, and in that instance it will work with the electric motor to power the vehicle, giving the battery an opportunity to recharge during braking. And of course, recent technical innovation with large passenger vehicles involves the use of hydrogen-powered vehicles that can be either through the internal combustion engine or with the hydrogen fuel burnt in a similar way to petrol, or they can be the hydrogen fuel cell that we've heard talked about this morning. The hydrogen can be stored under high pressure in compressed gas or liquefied form. Each presents its own issues with the inspection process. Indeed, generally, all inspection sites may not be designed for the safe inspection of these vehicles, therefore demanding modified or indeed new sites to accommodate them. Looking at changes to the inspection process, in this example, many vehicles, many buses have equipment fitted to the roof area to help with low floor access and egress arrangements. Inspectors and test sites may need to consider additional tools. In this site, it may be necessary to have a safety platform to be able to inspect the components on the roof of the vehicle, a totally new concept. Nevertheless, we must also consider that these vehicles will still be simply subject to our inspection processes. Look at the newest vehicle that sits outside, and it still has a braking system, steering, seatbelt, suspension, and the traditional components that fall in scope of our inspection. Finally, the inspection process for these new vehicles is indeed an ongoing piece of work, and CETA are well placed to be at the forefront of this work. Modern cars have safety systems that are checked through the onboard diagnostics system, the OBD system. So it would not be unusual for system checks to be added through the OBD system that relate to the electrical hybrid system. Inspectors may need tools to be able to check the systems. In any event, it must also be acknowledged that the inspector will only be able to carry out very basic or simple checks, as a complete check of the system may be too costly or too great, too high an effort to do so. We've heard mention earlier about other considerations, such as the inspection process after an accident-damaged vehicle is repaired and put back on the road. Indeed, what about modified vehicles? In some inspection systems in other member states, even inspections are carried out when vehicles are sold. So we would have to consider these as additional inspections. In summary, electric vehicles are not a new concept, but we need to continue to collect data about the aging of components and feed this into the inspection process. There are indeed risks to inspection staff, and these need to be well managed wherever possible by education and training. Often, federal regulations will need to be changed. Indeed, UAE Federal Law 21 could have no concept about electric hybrid vehicles that they would be on UAE roads in this time. And of course, the inspection process demands close cooperation between all the stakeholders. Thank you. I'm happy to take questions.
Thank you very much. Thank you very much, Andrew. Have we got any questions for Andrew at all? Questions? Yes, one.
Thank you. Yeah, very interesting presentation, thank you. The question that we've had to deal with internally, and I think you touched on that as well, public transport, buses in particular. It's one thing when vehicle manufacturers are able to educate a small number of garages or expert organisations who will help to deal with electric vehicles during maintenance issues. But something like public transport vehicles, buses, are in day-to-day use and maintenance schedules, and bus depots which are not prepared to deal with high-voltage electrical systems. So how do you envisage that transition happening for the public transport sector, where they will need to all of a sudden upskill their level of maintenance staff?
Thank you, Dennis. Excellent question. There will, of course, always be experts in the field. In the UK, we have recognised that where vehicles are often serviced or maintained, indeed maybe where that expertise lies. So in those situations, it may be quite reasonable and practicable for the inspection process to actually take place under the vision, under the supervision by the independent inspectors at the premises where those vehicles are serviced or maintained, so by the experts. So, and that might be reflected indeed with the motor vehicle, with the motor cars also.
And presumably the same will be true for organisations that operate their own fleets, would also have people that can play that same role.
Yeah, and indeed exactly the same circumstances. If you have a large fleet operator, either in the UK particularly a large fleet operator, then the independent inspection can still be carried out by an independent examiner, but actually at the premises where that inspection takes place will actually be at the fleet user's site.
Question there at the back.
Excuse me, regarding the annual inspection of the vehicle, okay, for example in UK it's run up by a government authority or by a third party who is professional in inspection of electric vehicle to certify that this vehicle is safe to run on roads. So it be certified by government authority or by a third party that's certified to inspect this vehicle.
In the UK, the inspection process on commercial vehicles is provided by the government. In in the UK, the inspection process for cars and light vehicles is provided by third parties under the supervision of the government. We are indeed one of the very few European countries that actually provides the commercial vehicle inspection facilities by government. Most of the other European countries, all of the inspections are provided by independent third-party assessment under the supervision of their government agencies.
Which I think is quite different to this region where virtually all vehicle testing and vehicle certification is done through a government agency